In this lesson sequence, students turn their focus to rocks. Our model of moving plates can explain some of the patterns where we find different minerals, but the rock cycle also moves rocks. And that's the focus of this section. We're also going to get a vision for how plate tectonics and the rock cycle interact, because plate tectonics is really one cause of the rock cycle as we look at the energy from the Earth being one of the driving energy sources for the rock cycle, along with energy from the sun. Together, those two energy sources cause all the changes that we see in the rocks. Now, different types of rocks have unique properties. They're so unique that Wegener was able to match them up from different continents across the ocean. Our phenomenon to start this section of lesson is that there is a rock that floats. In lesson 1.14, we introduce that phenomenon and ask, how can a rock form that floats? The teacher then creates a physical model using brown sugar and a microwave. Students compare the physical properties of the candy rock and the real rock, and then relate the processes that they use to create the candy rock to real-world processes that form igneous rocks. We pay particular attention to the energy source that causes melting, heat from inside the Earth. Lesson 1.15 begins similarly. We examine a rock and a kitchen table imposter. The teacher tells the students that the rock is formed without melting. So how can that be? Can students identify the imposter and figure out how it formed? Students make their own physical model of a rock using sand, glue, and pressure. They again make a flow chart relating their personal rock experience to the real world. Now, sedimentary rocks rely on the wind or water to erode other rocks, and so that means they rely on energy originally from the sun, and then they solidify using energy from the earth. In lesson 1.16, we wonder, how do rocks change after they formed? Students examine images of thin slices of a sedimentary rock and a new type of rock when viewed under a microscope. How do these rocks compare? Students again make a physical model of their own beautiful thin rock slices using a hairdryer and more pressure. These tools represent the energy from Earth's interior, which drives this part of the rock cycle. Lesson 1.17 is the rock cycle game, a kinesthetic model illustrating what can happen to rocks. Students start out representing rocks at different stations or locations on Earth, and then they roll a dice to determine what process they undergo and where they'll go next. They log their journey, and then write an adventure story of a rock's journey that demonstrates their understanding of the rock cycle. In lesson 18, the students complete their rock cycle stories and then convert those into a simple flowchart that they'll use again tomorrow. We end with the second concept checkpoint of the unit, focusing on the cycling of materials and flow of energy that drives the formation of different types of rock. In lesson 1.19, students complete and then share their flowcharts. They discover that not everyone's journey is exactly the same, but in all cases, the rocks underwent processes driven by the sun and Earth's energy. What differed was the order and the time scale. Students then complete written summary of the trends and patterns and discoveries they made from examining their peers' flowcharts. Students are now ready to take on the unit challenge and the culminating experience.